Hi there. Today we're going to talk about Lesson 3. We are in Course 2, Saxon, and this is Lesson 3. We're going to start out talking about unknown numbers. Those are numbers that we aren't given. A lot of times in a problem we're given a variable, or when you were younger you were just given a box and you had to find the number that was missing. A little bit of vocabulary for us to look at is equation. An equation basically says that two quantities are equal. For instance, 4 plus 1 equals 5. Well, 4 plus 1 is 5, and this side is 5, and therefore it's an equation because both sides are equal. It implies that both sides are equals and both of them should be equal to 5. Now, let's take the same equation and put an unknown in it. So instead of saying 4 plus 1 equals 5, we're going to say 4 plus r equals 5. Well, we know the answer is 1. But this right here is called the unknown. Later on, we will call it a variable. But we know that 4 plus some number r is equal 5. 4 plus some number r equals 5. Well, if we do the math, or we can do it probably in our head, we would know, even without our earlier experience, we would know that 4 plus 1 equals 5. So that some number r is actually equal to 1. And we've just solved our first equation. Now, the unknowns can show up just about anywhere. It can show up anywhere in an equation. Let me give you some examples. It can be 3 plus something equals 9. It can be something plus 12 equals 15. It can be 7 plus 4 equals something. And if we use multiplication for this, and it really goes across all of the operations, 4 times something equals 12, or n times 3 equals 15, or even 7 times 2 equals n. They really can go across all of those, and you can expect to see it in a lot of different problems. Now, how do we find out what those missing numbers are? That is our next thing we need to do. So I'm going to change pages here. We've been talking about inverse operations. And remember, inverse operations were being able to take things, go backwards to solve a problem, or using the opposite operation. So for instance, if we have a missing number, n plus 16 equals 20. We want to solve for n. And this is an addition problem. Well, the opposite of addition, or inverse, opposite and inverse, I'm going to write that up here because they are basically the same when it comes to math. The inverse for addition is subtraction. So if we want to find out what n is, I think it would be kind of smart, we do this in our head anyway, to subtract 16 from 20, and we get 4. Well, we all know that if we subtract from one side, we have to subtract from the other. So if we subtract 16 from this side, it goes away, and we're left with n equals 4. Hence, 4 plus 16 equals 20. 20 equals 20. Check. It is correct. Here's another example. Okay, I like to do examples with these. N plus 35 equals 80. Let's use the same logic we did last time. We want n by itself, and we in our head know that if we take 80 minus 35, since this is an addition problem, we want to take 80 minus 35, so we'll take 35 away from 80 there. And if we subtract it from one side, we have to subtract it from the other. This goes away because it equals 0, and n is equal to 45. Let's check it out. 45 plus 35 equal 80. Well, does it? Well, 40 and 30 is 70, plus the two 5s, that's another 10. And by golly, 80 equals 80. Check. Okay. So, and we can have it in a long string of numbers. For instance, you could have it like this. Here's another example. 3 plus 2 plus n plus 6 plus 11 equals 35. Now, we want to find n. Now, there's a whole lot of numbers on that left-hand side, so I would say let's combine a few of them. We could take 3 and 2 together, and that's 5 plus n plus 6 and 11, I think is 17, isn't it, today? Equals 35. Now, we're still not quite there yet because I think it would be smart to get these two together. And 17 plus 5, well, let's add it up over here. 5 and 7, 10, 11, 12. Okay, so we end up with 22 plus n equals 35. Now, it's an addition problem again, so we have to do whatever the opposite is, which is subtract. So we'll subtract 22 from both sides. This goes away, and n is actually equal to 13. And we can substitute back in 3 plus 2 is 5, and 5 plus 13 is 18, and 18 plus 17 is 35. Okay? Now, looking at a couple more operations with this, we have operations with missing values in subtraction. So let's look at subtraction. Okay, now we need to find the inverse of subtraction. Well, guess what? That is addition. So, if we have a missing number and we need to solve and try to find that number and it's a subtraction problem, we're going to use addition. So here's an example. P minus 24 equal 17. Now we want to find out what P is. So we need P by itself, and we got this minus 24 here. So the opposite of minus 24 is plus 24. So we'll add 24 here. That'll get P by itself, and we're going to add 24 here because adding was the opposite of subtracting. That goes away because it becomes 0, minus and plus. They cancel out. So P is equal to 41. Now, if we look over here, we can go ahead and do our check on the right hand and say, okay, 41 minus 24, does that indeed equal 17? Do the math over here. 41, 24, 4 is a 3. 4 from 11 is 7, 2 from 3 is 1, and by golly, 17 does equal 17. Check. Okay, multiplication. Okay, and we do need to know what is the inverse of multiplication. Yes, it is division. So, division, that's what we're going to use if we have multiplication and we are trying to solve for a missing number. So let's just use 8 times k equals 88. Now we all know the answer to that because we know that 8 times 11 is 88. But let's pretend we don't for just a second. Okay? We have 8 times k. We know it's times because it's right up against the variable. And we want to solve for that variable, or we want to solve for our missing number. So it's multiplication, so instead of multiplying, let's use the inverse of multiplication, which is to divide. We'll divide this side by 8 and this side by 8. This here becomes 8 over 8, which 8 over 8 today is 1. K equals 88 divided by 8, which is 11. Now, the 1 doesn't have to stay there. 1 times k is k. Remember the identity element for multiplication? So we could just leave it as k is equal to 11. Now we go over here and check it. 8 times 11 equals 88 because you substitute your 11 for your k, and by golly, 88 does equal 88. Okay? Now, the last one we can look at here is division. And division is pretty much the same way. We need to know what is the inverse of division. Well, yeah, it's multiplication. So, if I have a over 7 equals 6. Okay. Well, I probably need to think about what number is divided by 7 and that equals 6. I know that number. Yeah, I think it's 42, isn't it? So, it says to multiply. So, since the 7 is down here, we're going to use a little thing called reciprocal. The reciprocal of, we'll figure 1 over 7 is 7 over 1. We'll multiply this side times 7 over 1 and this side times 7 over 1. Well, 7 over 1 is just 7, and these guys cross reduce. We are left with a equals 42, which we already knew that a had to be 42 because 42 divided by 7 was 6. Okay? Alrighty. I hope that's helped you today, and I hope this assignment is not too tough and that you have a good time doing it, and bring your questions to class.